All right, so here we're looking, the construction of a sign chart is going to play an important role in using the derivative to analyze and sketch the graph of a function of f. So the partition numbers for f prime are central really to constructing of these sign charts and also to the analysis of the graph of y equals f of x. So the partition numbers for f prime that belong to the domain of f are called critical numbers. So again, they belong to the domain of f. Now we're assuming the f prime of c doesn't exist at any point of discontinuity of f prime. Okay, so that's kind of a key piece there. Now, critical number. So it's a real number x in the domain of f such that f prime of x is equal to 0 or f prime of x does not exist. Those are called critical numbers. And so that's what we're going to be looking for in some of the problems here. They're going to ask you, what are the critical numbers? And so moving on to one of those, it says find the critical numbers of f, the intervals on which f is increasing, and those on which f is decreasing. And they give us the function f of x equals 1 minus x cubed. Well, first things first, we're in the derivatives chapter, so let's take the derivative of that. So we take the derivative of this, well, this goes to 0, so we get a minus 3x squared, okay? Now, if we look at the critical numbers, that's when this is equal to 0. So when minus 3x squared is equal to 0, when is that? Well, that's only divide by 3, you get 0. Take the square root of 0, you get 0. So when x is equal to 0, okay? So the critical number is x is equal to 0, okay? So the critical number, maybe I should say, of f is x equals 0, okay? All right, so with that said, then we can do our sign chart. So we know that 0 is going to be a key one. So let's plug in, I don't know, maybe a 2 and a minus 2 because those are easy to square and do things with. So what is f prime of x going to do? Well, if we plug in a negative 2 and square it, we're going to get a positive 4 times a negative 3 is going to be a negative 12. So we're going to get negative over here. What if we plug in a positive 2? Well, same thing happens. Positive 2 squared is 2 times negative 3 is going to be a negative 12. So it looks like we're basically decreasing over here, and we're decreasing over here. Now, what do we know about this function? It's basically it's continuous. It's going, from our function is over the whole interval from minus infinity to infinity. There's nothing restricting it. And so if there's nothing restricting it, that means that 0 could be part of this. And so with that being part of that, that means it's continuous. And so basically we're decreasing over the whole range, which is from negative infinity to positive infinity. Okay, so we're decreasing from all the way this way to all of the way that way. And so, I guess what we can say then is decreasing from negative infinity to infinity is what it's doing. There's no increasing, it's only decreasing. So that's kind of a key for this one. Okay. All right, let's stop with that one and go some more.